Okay, another key option is the no re-advertise. No re-advertise says that you will not redistribute the static route into another protocol, where specifically in JunOS we call that exporting. So exporting is the equivalent of redistribution in iOS. So if we are exporting static routes to OSPF or exporting them to BGP, and if you have any static routes that have this keyword tagged onto it, no advertise or no re-advertise, it means that you're not going to do redistribution. So if you want to keep this as a locally significant static route and make sure it doesn't get leaked into dynamic protocols, you would set no re-advertise. Now, just like in iOS, JunOS also does support virtual routing and forwarding instances, which basically are multiple copies of the routing table. In JunOS specifically, these are defined under routing instances. Now, a routing instance is technically more than just a VRF. There's other applications for this, like layer 2 VPNs or virtual private LAN services, where a VRF is the L3 VPN functionality of the routing instance. Now, a very basic example of this would be we create the routing instance. We say that the instance type is a VRF. We specify what interface that the VRF is applied to. Then we give it the route distinguisher and the route target values. Now, the distinguisher and target, we'll see a little bit later when we're looking at MPLS L3 VPN implementation. Those are going to be functions of the VPN v4 route. So when we do an advertisement into multi-protocol BGP, route distinguisher is going to be part of the BGP best path selection. The route target value is going to be the extended community that we use to control the membership of the route. But even in the case that you are doing VRF Lite, which is just a multiple routing tables without doing MPLS and without doing multi-protocol BGP, you still are required to define both the route distinguisher and the route target. So if we were to create this table here, we'll see that there's a key functional difference here between JunOS and iOS with this, that if we edit routing instances, and we're going to set whatever we call it, VRF A, and we say the instance type is a VRF. Okay, we'll see that there's a lot of other options here, but there's not all of them are really relevant to our discussion. For the most basic example, like this would be where you say, I want an instance of a control plane protocol for that particular table. Where, like in the case of iOS, if you have a VRF and you want to run a VRF aware process, you normally would put that under the global protocol and then specify the VRF. Like in the case of EIGRP, for example, you create an EIGRP process, then you say I have VRF A, and then it has this autonomous system. Or I say I have ISIS globally, and then under that I have the address family for the VRF. In the case of JunOS, it's under the routing instance. Then we create the multiple copies of the protocol. So we'll say like set protocol OSPF, for example. Okay, that's creating a VRF aware instance of the control plane. But in our case here, we set the instance type. The instance type was set to be a VRF. Okay, if we look at the other instance types, this would be things like a VPLS, if we're doing multi-point layer 2 bridging over MPLS. L2 VPN, that's going to be for a point-to-point layer 2 pseudowire. But in our case, it's a VRF, which is L3 VPN, so layer 3 routing table, essentially. Okay, we then set what is the interface we want to apply it to. So let's say, for example, here that we're going to apply it to this interface here, gig E000.46. So interface is gig E000.46. That's the unit number is 46. We need to set the route distinguisher. Route distinguisher. Okay, so same format as iOS. We'll say 1.1. Doesn't really matter what it is. Set the import and export policy. So the VRF target, we're talking about the VPN v4 route target value. Export, and then if you just type anything in here, I'll show you the syntax format. The syntax format is target : and then the actual target number. So target : like 1010. Now if we were to commit this, let's say commit check, we have to define both the import and the export policy. So even in this case, even though we're not running BGP and we're not doing MPLS, If we want to create another copy of the routing table, we still need the route distinguisher plus the import and export target policy. We'll say set the import target, then show pipe compare, commit and quit. Commit checkout failed, interface gigi 00046, interface not configured in this instance. Let's say show top show interface gig E 00046. I may need to, let me define the instance first and then we'll come back and apply this. Let's say show, let's say delete interface gig E 00046. Delete VRFA. Commit. Then I may need to, let's see, where did I set the interface? Okay, so the name of the VRF is VRF_A. Interface is gig E 00046. I'm not 100% sure why it's not taking that interface. It did apply to a different one. Oh, I think actually the reason why is if we, let's say top show. I have this running OSPF is what the issue is. So there's a global OSPF process, and then I'm trying to move the interface into a VRF. It won't allow that because I would have to move the IGP process under the routing instance under the VRF. So if we were to say, let me do this, let's say under edit, let's say delete protocols OSPF. Then we will set the routing, or set the VRF on the interface, commit. There we go. Okay, so now if we look at the, let's exit out of the config, and let's say show route, there should be 3 different tables now. Well, technically 4 different tables. There is the global routing table, which is inet.0. There is the VRF instance of the table for IPv4. So that includes gig E0045 and 46. 46 here. Then we have the IPv6 table, inet 6.0, which is the global one. And then we also have the one that is for the particular VRF. So one of the big functional differences then here between iOS and JunOS is that you can move the interface between tables without having to delete its config and then reapply it. Where in the case of iOS, if we were to say this, if we were to create a VRF, IPVRF-A, and then go to the link level and say IPVRF forwarding A, it removes the addresses. Then you would have to reapply them, and also by default, the VRF is only enabled for IPv4. Where in the case of iOS, we would go to the VRF definition, activate address families IPv4 and v6, then apply the VRF membership to the link level. So the end result is really the same, is that you have a logical copy of the routing table, but of course the syntax and the order of the steps are a little bit different between the two platforms. So we'll look at some other examples of this when we're looking at MPLS Layer 3 VPN. But the functionality is similar ultimately between the two different OSs. Then from a verification point of view, it's creating two additional tables. So now we have a table in our case which is show route, and then what's the table? The table is now vrf_a dot inet0 and inet60. These are respectively the IPv4 and IPv6 unicast tables that are for that particular VRF. We can also say show route instance and then the VRF. This is essentially the equivalent of in iOS where you just say show VRF or show IPVRF. So what this will show us is, and if we show the VRF instance detail, this also tells you things like the import-export policy. This is going to be useful for the MPLS L3 VPN config. So what's the route distinguisher, what's the route target import and export policy? But right now, since we're not running MPLS, we're running just regular IP routing, these values aren't used for anything. It's basically just a placeholder. So like I said, we will come back to, in a little bit later, some of the more details of the rest of the L3 VPN config. But just on its own, in terms of routing, we can have multiple virtual routing and forwarding instances. We can have multiple copies of the routing table. So if we look at our full config here, let's say show config, routing instance, and show config routing instance pipe display set, then the rest of the VRF config would be going under or essentially anything related to the VRF at all is going to go under this routing instance now.